Hello, 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 Algebra 1. So, today we're going to be talking all about intercepts. Easy mode, finding intercepts when they just show you the graph. Semi-easy mode, finding intercepts when they give you the equation. And then the really challenging lesson, how do you find an intercept when you're giving xy coordinates in a table? That's what's coming up once we get started. So we're going to give everyone a few minutes to log in, and then we'll get to it. And this is for assignment 8. 6th period only, assignment 8. Let me go ahead and put a few things on the screen to make sure everyone is absolutely sure what they're looking at. Let's see. Okay, so 1. Morning, RJ. Just giving everyone a few minutes to get themselves logged in, or uh, we'll just get started without them. Well, they got 7.5 minutes to log in to join us. Less than 5 minutes. Time for me to start getting some problems set up for us to practice. Well, there's a siren. That means it is time to start. Welcome back. Okay, we're going to get things started here. So, like I said, today is all about intercepts. And some of these problems are much, much, much more simple than others. So, why don't we go ahead and start with intercepts from a graph. Okay. Got a few different resources. I'll try this one out. Okay, so get rid of this. Let me put these words on the screen or else someone's gonna say they didn't know. All right, so let's have a practice problem. Actually, you know what? Before I even do that, let's talk about what intercepts are in general, since we're going to be nothing but just for anyone who isn't familiar with this term, there are two kinds of intercepts. Actually, let me do 4 quadrants. Let's say that was perfectly straight. So you got your y-axis and you got your x-axis and you got your origin in the middle. So when you've got a function going through your system like so, it will connect with your axes sometimes. So the x-intercept is where your function or your line connects with the x-axis, and your y-intercept is where your function connects with the y-axis. Now, an interesting thing about their coordinates, y-intercepts will always have an x value of 0. And x-intercepts will always have a y value of 0. And it's really important we all understand that. And an x-intercept always has a y value of 0, and a y-intercept always has an x value of 0. Those are really, really important to understand. So when we're doing the most basic of the basic problems, get all this. So check this out. Hang on, didn't mean to. I drew on accident. Let me catch that again. It's great production quality, watching a math teacher talk to himself. Okay, let's try this. Okay, look at this one real quick while I put the words practice problem back on the screen so no one can argue. So what I'm asking is that, oh, hey, Lily. So what I'm asking is that you guys be able to identify the intercepts just by looking at a graph. So I'm going to go ahead and note that one of the intercepts is here, and one of the intercepts is here, and all we have to do is write down what those spots are. So like this one is at 0, 2. And this one is at negative, whoa, right over here, negative 6, 0. So now the question is, which one's which? Which one is the x-intercept and which one is the y-intercept? The easiest way to tell is to look at the axes. This is the y-axis, this is the x-axis. So whichever one touches the y-axis is the y-intercept. Therefore, this one is your y-intercept. And since this one is on the x-axis, this one is your x-intercept. And like I said just a moment ago in the demo, x-intercepts always have a y value of 0, and y-intercepts always have an x value of 0. So this is the first most basic kind of question. You'll have one of these for assignment 8 here in a little bit. It's just identifying the intercepts from a graph. So if we were to try another one, let's see if we can get it right in chat without any help. Go away, go away, go away, go away, go away, go away. Erase, 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 erase. So look at this one. All right, chat. Take a look. See if you can tell me what you think the y-intercept is and what the x-intercept is. If you're watching at home or on YouTube or on a phone and you cannot see where you think these things cross, this one is here, this one is here. Now one of these is exact, and one of these I guess we'll just take an educated guess. So if I had to guess, I would say that the y-intercept is at 0, -4. That's the easy one. Now it takes some further calculations to do because I think this equation goes through 1, 1. But if I had to guess, I would say that the x-intercept is at like 1.8-ish, 0. The one you'll have for your problem today, there will be no ambiguity. You'll be able to say exactly what it is. This kind of a problem is what we're going to get to in a minute, where we're trying to find the intercepts from an equation, which aren't, it isn't that bad. Okay, so that covers just finding the intercepts from a graph. All you have to do is look at where they cross the axes and write it down. That's it. So let's try something that actually requires us to do a little bit of work. I'm going to pick a different color. This is much easier to read. Okay. So now what we're trying to do is find the intercepts, but instead of them giving us a picture to look at, what if they only gave us an equation? We got one for us. Just got to capture real quick. Here we go. Drag it over successfully, maybe. Here we go. All right, so what if they gave us this? If this was our problem, how in the world will we find our intercepts? Well, remember, if you're on YouTube, you can go back and check, but for those of you here live, remember I said that x-intercepts and y-intercepts always had a 0 somewhere, and that's where this really comes into play. So our x-intercept is always going to have a y value of 0. And our y-intercept will always have an x value of 0. And that's how we're going to crack this code. So let's try this when we put in a 0 in the y spot. So that would be 4x plus 5 times 0 equals 20. So again, if y was equal to 0, what would happen? Well, that means that 4x would equal 20 because anything times 0 is 0. Then we could divide both sides by 4. 4 divided by 4 is equal to 1, so that's 1x. And 20 divided by 4 is 5, so x would be equal to 5. So apparently, when y is equal to 0, x is equal to 5. So we just discovered our x-intercept. And now we can do the exact same maneuvers. If we put 0 in for the x value, moving my menu. Okay, so if we had 0 in for the x value, that means we would have 4 times 0 plus 5y equals 20. So 4 times 0, again, anything times 0 is going to be nothing. That makes 0. So we end up with 5y equals 20. We can divide both sides by 5 to find out that y equals 4. Because anything divided by itself is equal to 1, and 1y is the same as just saying y. Well, so there it is. So our x-intercept and our y-intercept are right there, and it's found by a very simple understanding of that x-intercepts have y values of 0, so you can just plug in a 0 for y and find out what x is, and our y-intercepts have an x value of 0, so you can put in a 0 for x and figure out what y is. Let's try another one. I bet you guys could get this right on the first try without me. Let's see. Capture. what about this one? And what we're trying to find are our intercepts. And you got to remember that the x-intercept always has a y value of 0 because it's on the x-axis. And our y-intercept always has an x value of 0 because it's on the y-axis. And that's how your problem really starts. If you're watching on YouTube, I encourage you to pause right now, work out the problem, and come back and see if yours looks like mine. So if I was going to put a 0 in for x, let's see what that would look like. That'd be 2 times 0 minus y equals negative 4, which means that negative y is equal to negative 4 because anything times 0 is 0. So this is basically a negative 1y. So if we divide it by negative 1 on both sides, anything divided by itself is equal to 1. So it leaves us with y equals negative 4 divided by negative 1 would just be positive 4. So apparently when x is equal to 0, in this system, x is equal to 4. So there's our x-intercept. Now, pretty much the same maneuver. What if y, for the y-intercept, what if x was equal to 0? So that would be, ooh, did I make a major boo-boo? Let me back that up. Wait a second. Yeah, I did. Oh, massive undos, massive undos, massive undos. Go, 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 go. Back it up, back it up, back it up. So glad I noticed. It would be so embarrassing if this was being recorded and I made such a blunder. No one in chat stopped me, so I get a chance to fix myself without any embarrassment because I did notice that I made a mistake. Okay, what was I saying? This crazy person on the other side of the camera just tried to say, okay, I'm replacing x a 0 for the y value, not the x value. So this should be 2x minus 0 equals negative 4. Yeah, x-intercept, not y-intercept, the x-intercept. So we're saying that y is equal to 0. Dirty dir. Okay, so that means we'd have, and minus 0 doesn't change anything. So we just say that 2x equals negative 4. So we divide both sides by 2, and you would get x equals, okay, so negative 4 divided by 2 would be negative 2. Whew, that was close. Okay, let's say that again. When y is equal to 0, check. X turns out to being equal to negative 2. Woo, that was close. So our x-intercept is at negative 2, 0. So glad no one saw that, he said to YouTube. Okay, so if we're going to find the y-intercept, we want x to be equal to 0. And now I am going to put a 0 in the x spot. So 2 times 0 minus y equals negative 4. Okay, RJ, I guess we're going to check that in a second. So if we were to say, well, 2 times 0 is just 0. That's nothing. So I would end up dividing. Okay, so this is basically a negative 1 times y, so I can divide by negative 1 on both sides. So y equals negative 1 divided by negative 1 is 1, so that's 1y. 4 divided by, I'm sorry, negative 4 divided by negative 1 is just positive 4. So when x is equal to 0, and that is where the x goes, y is equal to 4. So yeah, these are the two intercepts. And you want to make sure you write them as coordinate pairs. You don't just want to say that x equals this and y equals this, because that'll be confusing. That'll be ambiguous. People will think you're only talking about one coordinate, when in fact we're talking about two coordinates. Awesome. All right, the people here in chat, should we do one more practice problem like this, or should we move on to the really hard stuff, finding intercepts from a table? Hard stuff it is. Now, the stuff we just did, we're going to have to do that in this next problem. There's just more work to be done before it. Okay. So what do we do when they only give us a table of information? So they give us this table, but they didn't give us the equation. They didn't draw us a picture. So step one is we have to take this information, this table, and turn it into an equation, and then we can do the stuff we just did. So the next question is, how do we turn this into an equation? Okay. So let me just I feel like I should put what I just said on screen. Okay, so the equation is going to need a slope. And to find slope, we need to do, one of our favorite things in the world. We need slope, and that is the change in y over the change in x. And that's going to be y2 minus y1 over x2 minus x1. And we've got a whole bunch of x's and a whole bunch of y's. I don't really care which, so I am just going to arbitrarily decide to use these two right here. Use a different color, make this a little easier to see. So I'm just going to go ahead and designate that this 40 is going to be my y1, and this 48 is going to be my y2. And it makes this 5 my x1, and this 6 my x2. So y2 is 48. Y1 is 40. Hey, Abby. Good to see you. You just joined us for the hard stuff. This will be the hardest problem of the day because it just requires the most work. So 48 minus 40 over 6 minus 5. So our slope would be 8 over 1, which is just 8. Okay, so we got the slope. Now, we're going to have to figure out, well, I guess we can find the y-intercept kind of early on in this process. So the equation for, if I'm just going to use slope-intercept form, that's y equals mx plus b. And b is our y-intercept. So what we're going to do, we're going to take, let me grab a different color. We're going to take this 8, and we're going to plug it in for m because that's our slope. And then we can pick any one of these xy pairs that we want and plug them in for the y and the x. So I think I'm just going to go ahead and choose this one right here. I'm going to use this 5 and this 40 as my xy pair. And then we'll be able to figure out what b is, which is our y-intercept. So, okay. So y would be 40. Our slope is 8. Our x value is 5. Right? So x value is 5. Okay. So that means that 40 is equal to 40 plus b. Hopefully some of you have already spotted what we're going to get here. Well, if we take away 40 from both sides, they both become zeros, which means our y-intercept is actually equal to 0. So just so we're keeping track, the whole goal was to find the intercepts. And now I know that we have an intercept at 0, 0. Okay. I guess that's both. That's the y-intercept and the x-intercept if you think about it, because it's going to go through the origin. Yeah, it wouldn't be possible for a linear equation to have another intercept, because this guy is going to be going through 540. So let's just say that that's a really steep line, by the way. So this is 5 and this is 40, and it goes to like right there. So I'm trying to make it look good. Yeah, something like that. So this one actually has one intercept at 0, 0. All right. I gotta check on a noise I just heard from the kiddos. So I'm gonna post a new one and I'm gonna see how you guys do with it. So let me back up some. Let me see if I can just snipe this. Oh, sweet. No. Erase, erase, erase. All right, maybe this one won't have an origin intercept and we will be able to do more. Let's see. So the job is to try to turn that into an equation. Anyway, I'll be right back. Okay, sorry about the delay. So, let's see what this one turns out to be. Okay, so the first thing I'm going to do is figure out the slope. Because the goal here is to figure out intercepts, and the first thing to do is figure out the slope. So I'm going to just take two of these. I'm going to take the first two. Oh, they all have negatives somewhere. I guess I'll just grab these two right here. I'll make this y1 and y2, and this will be x1, and this can be x2. So that'd be -5. So be -5 minus a -3. This is to find the slope. -5 minus -3 over 5 minus 3. The opposite of subtraction is addition. So -5 plus 3 will be -2. 5 minus 3 is 2. So our slope is -1. Okay. So then we'll take our equation of y equals mx plus b. And let's figure out what the y-intercept is. So I know that m is going to be -1. And then I can just pick any of these. So I guess I'll just I'll do this one, the 5 and -5. So I'll put in 5 for x. And I'll put in a -5 for y and see what happens. So -5 equals -1 times 5 plus b. That means that -5 equals -5. Oh, it's 0 again. Okay. This is lame. I want something that comes out with a non-origin intercept. So basically, we add 5 to both sides. And we end up figuring out that b is equal to 0. So the y-intercept is 0. The y-int always has an x value of 0. And now we just found out it has a y value of 0. And that would be the intercept for both the x-intercept and the y-intercept. Let me see if I can actually pick one that doesn't have an origin intercept. That'd be great. It seems too strange that so many would. Okay. This one should not have an origin intercept, which would be perfect. Okay. So let's try this one. So if we can turn this into an equation first, and then we can figure out what the y-intercept is, and then we can put in a 0 in the right place and figure out what the x-intercept is, that's the plan. So we want to fill in the equation y equals mx plus b. We've got a bunch of x's, we've got a bunch of y's, but we don't have the slope yet. So let's go ahead and figure out the slope real quick. The slope is y2 minus y1 over x2 minus x1. And we get to make some arbitrary choice as to which values we use. I'm going to go ahead and grab these two. Oh, wait, hang on. I'm a sucker for positive numbers. I'm going to grab these two sets right here because they're both positive. It does not truly matter, but it's my show, so I'm doing positive. All right, so this is y1, and this is y2 because they're in the y column. This is the beginning, this is the end. So then this would be x1, the beginning, and this would be the end at x2. So I plugged them into the formula correctly, and that means y2, which is 35, minus y1, which is 7, all over 10, that's x2, minus x1, which is 3. 35 minus 7 would be 28, I believe. And 10 minus 3 is 7. And 28 divided by 7 is equal to 4. Okay, so we have our slope. Our slope is 4. Okay, so now what we're going to do is pick one of these. I'm going to go ahead and take the smallest positive variables. So our x and y, I'm going to use 3 and 7 for x and y, and I've got 4 for our slope. So let's rewrite our equation as such. So y is equal to 7, m is equal to 4, x is equal to 3, and we don't know what the y-intercept is yet, but that's what we're trying to figure out. What is the y-intercept? Okay. So that means that 7 is equal to 12 plus the y-intercept's y value. So if we were to take away 12 from both sides, that would leave b by itself, which is what we want. 12 minus 12 is nothing. So 7 minus 12 is negative 5. And that's what's equal to b. Aha! So here's what we just found out. So our y-intercept, and that's what the b stands for, by the way, the y-intercept is at 0, negative 5. So we've gotten our y-intercept. Now, how do we use the information we've uncovered here to find our x-intercept? Well, we know that b is equal to negative 5. Therefore, we can rewrite the equation as this. Here's our equation. Let me get a different color. So now we know that y equals 4x minus 5. Okay, that is the linear equation right there. Now, what we know about x-intercepts is that their y value is always 0. Our x-intercepts always have a y value of 0. So if we want to solve for the x-intercept, all we need to do is jam the 0 in for the y value. So let's just say that 0 equals 4x minus 5. Okay, fine. I accept that. So I can just add 5 to both sides of this equation. Not 15. So I end up with 5 equals 4x because negative 5 and 5 cancel each other out and make it 0. Now I can divide both sides by 4, and we'll have a fraction answer, but that's okay. 4 divided by 4 is equal to 1, so I've got 1x. So I'm going to just move my scrap work over a little bit. So what we end up with is 5/4 is equal to 1x. So the y-intercept is at 0, negative 5, and the x-intercept is 5/4 0. So yeah, sometimes you might end up with a fraction answer, which is fine. Not all lines are going to be perfect. I can't promise, but I'm almost sure that the problems I gave you for your actual assignment will not have fractions as answers. Almost positive. Almost. They might, but they might not. Okay. I feel like doing one more of those as a practice problem before I just post your first 3 problems for assignment 8, because these do require quite a bit of work. And then, so one more practice problem, just like that one. And then we will move on to today's questions. Okay. Bum, ba-dum, bum, bum. I hope everybody made their bed today. Every good day starts off with a made bed. Okay, so our goal right now is to figure out what the intercepts are, but that takes a process. First, to do this, I should turn this into I should get the equation for this function, and then find the intercepts is much, much more possible. So we're going to start with the equation. We'll use slope intercept form, which is y equals mx plus b. And the first thing we're going to figure out is the slope. The calculation for slope is y2 minus y1 over x2 minus x1. So we can pick any two coordinates we like. So I'm going to take the two small. I thought I was drawing a box. I'm going to take the first two positive coordinates I can because I'm lazy like that. I like positive numbers. That means that 9, this is the y column, so 9 would be my y2, that's the ending, and my beginning y1 would be 6. The x column, x2, the ending would be 7, and the beginning x1 would be 4. So if I plug these in correctly, that'd be 9 minus 6 over 7 minus 4. Now that'd be 3 over 3. Wait, hang on, 9 minus 6. Okay. So my slope is equal to 1. Check, got that. Okay. So now I've got slope. So I can pick any two coordinates I like for x and y for my intercept form. So let's choose. So I've got 1 for slope. I'm just going to go with these right here, this 4 and this 6. So that'll be my x, my y value. So y value is equal to 6. My slope is 1 times the x value, which is 4, plus my y-intercept value. Okay. That means that 6 equals 1 times 4 is 4, plus b, which is the y-intercept, which is one of the things I want. Again, we're trying to find intercepts here. So if I were just to take away 4 from both sides, I'd end up with 2 is equal to b. So there it is. So, okay, so there's one of them. So my y-intercept is at 0, 2. Okay. Because that's what b is. B is, in this equation, in this model, b is the y-intercept. And we all know y-intercept has an x value of 0. So that's that. So now how do I get the x-intercept? Well, let's rewrite the equation that we just kind of uncovered for ourselves. And that is y equals 1x plus 2. That's our linear equation. The slope is 1 and the y-intercept is 2. So there it is. Now, from what we've been studying this whole time, we know that our x-intercepts have y values of 0. So what if we took this equation and just jammed a 0 in for the y value? Straight lines are difficult, apparently. Wow. 4 times the charm? Maybe my hand's getting tired. Okay, we're going to draw a 1 here. It's going to happen. That's bad. That's good enough. So 0 equals 1x plus 2. So again, I know that my intuition, I know that x-intercepts have y values of 0. So I took my equation for this line, I put a 0 in for the y value, and now I should be able to figure out what x is. So if I were just to subtract 2 from both sides, I'd end up with -2 equals x, because 1x is the same as x, and anything subtracting itself makes 0. So my x value would be -2. So my y-intercept is at 0, 2. My x-intercept is -2, 0. So there are your demos for lesson 8 so far. So now I'm about to post questions 1, 2, and 3 for your assignment. And I wish you luck. If you're watching live, I'll give you a couple seconds to write them down, but basically everyone's going to have to go to YouTube and pause it and then work it out on paper. Okay, so give me a second and your questions will be posted. Okay, one moment. I'll try to make that one bigger and easier to see. I might even have to do one question and then like on screen at a time. What do you guys think, chat? Is the graph too hard to see? Okay, 1 second. Ah, I'm gonna go ahead and put a dot. Here and here. Let me check something while you guys on chat are working this one out and writing down your answers. Let me check something real quick. Not you. Talking to myself. That's okay. Okay. Chat. Can you confirm or disconfirm that you're able to see where those two dots are? I'll go ahead and say it. Yep, they're going to be decimals. Okay. All right, let me go ahead and label this as question 1 then. Okay. Now, question 2. Come on board next. If you didn't have time to do this, chat, you'll have to go back and watch the YouTube. Okay, so this one I'm asking for the y-intercept only. Still plenty of work involved in getting that. Okay. And now I'm going to be posting question 3. Okay. And for this one, just remember that y-intercepts always have a 0 somewhere, and x-intercepts always have a 0 somewhere. So, yeah, there is that. Okay, well, I'm hoping today's stream and video have been useful to you. I hope everything works out for everybody and everyone does very well and they're all successful. But if you're having trouble, email me. Some of the best emails I'm getting are people taking pictures of their scrap work and saying, "Hey, Mr. Matthews, I don't think I got this one right. What went wrong?" And then I'm actually able to respond to your scrap work, which is amazing. I'm getting a lot more upticks on videos, obviously, because people have to watch them to get the questions. And yet still, I've got some people, email me saying, "I don't get it. Where are the questions?" Well, check your classroom for information every week. Stay safe, make your beds, take care of your families. And I guess I'll conclude today's lesson. So if you have any questions, email me. If you're curious about your grade, email me. I can tell you that way as well. And I'll see you guys next time. Take it easy.